On the drawing boards at the Philadelphia Navy Yard in March 1941, USS Montana existed as 23,000 sheets of technical plans, 921 feet 3 inches of battleship, 121 feet 2 inches of beam, 12 16-inch 50 caliber, Mark 7 guns arranged in 4 triple turrets, 70,965 tons of displacement at full load, the largest, most heavily armored, most powerfully armed battleship the United States Navy would ever design. She would never feel water beneath her hull. 28 months later, on July 21, 1943, 5 names disappeared from the Naval Register. Montana, Ohio, mine. New Hampshire, Louisiana. Hull numbers, Bravo, Bravo 67 through 71. Not a single keel plate had been laid, not one rivet driven. The age of the battleship ended not with gunfire, but with a bureaucratic memorandum redirecting steel allocation to aircraft carriers. The decision took approximately 15 minutes. This would prove to be the correct choice. At 0930 hours on December 7, 1941, the first wave of Japanese aircraft struck Pearl Harbor. 8 battleships of the United States Pacific Fleet lay moored along Battleship Row. By 1300 hours, 5 were on the bottom. 2 more were heavily damaged. One, USS Nevada, had attempted to sortie and been deliberately beached to prevent her from blocking the harbor channel. The backbone of American naval power in the Pacific had been effectively destroyed in less than 4 hours, but the 3 aircraft carriers assigned to the Pacific Fleet had been at sea. This fact would determine the course of the war, the future of naval warfare, and the fate of USS Montana before her first steel plate was ever cut. The story begins 3 years earlier. In the summer of 1938, when the General Board of the United States Navy convened to discuss the next generation of American battleships, Admiral Thomas Cunningham Hart, head of the General Board, faced a fundamental question. The Washington Naval Treaty System was collapsing. Japan had refused to sign the Second London Naval Treaty in 1936. The escalator clause would soon allow battleship displacement up to 45,000 long tons, with main batteries of 16-inch guns. The United States had 10,000 additional tons to work with compared to previous designs. How should those tons be allocated? 2 schools of thought emerged immediately. The first advocated for speed, fast battleships capable of 33 knots or more that could operate with the carrier task forces that were beginning to dominate Navy planning. These would become the Iowa class. The second school argued for protection and firepower, slower battleships, 27 to 28 knots, that could absorb tremendous punishment and deliver devastating broadsides. These would eventually evolve into the Montana class. The debate consumed 18 months. 9 different design studies were produced between February and August 1939. Designations range from Bravo Bravo 65-1 through Bravo Bravo 65-8. Displacement proposals ranged from 52,500 long tons to 67,000 long tons. Armament options included 9 16-inch guns, 12 16-inch guns, or even 9 18-inch guns. Speed requirements varied from 27 knots to 33 knots. The board could not reach consensus. By July 1939, Navy senior leadership remained sharply divided on design priorities. Cost projections troubled Secretary of the Navy Frank Knox. The larger designs would require new construction facilities. The Philadelphia Navy Yard would need to expand its building ways. The New York Navy Yard in Brooklyn would require similar modifications. Norfolk Navy Yard at Portsmouth, Virginia faced dredging requirements for the deeper draft vessels under consideration. Then, intelligence reports arrived from the Pacific. Japanese agents operating in Panama had been observed measuring the dimensions of the canal locks. This suggested Japanese battleship designs were deliberately exceeding Panama Canal width restrictions. American naval architects had always designed within canal constraints. Every United States battleship since 1914 had been built narrow enough to transit between the Atlantic and Pacific via Panama. Maximum beam for canal passage was 108 feet. The new Japanese battleships, intelligence suggested, would exceed 120 feet of beam. American designers suddenly faced an opponent unconstrained by the Panama Canal limitation. On August 19, 1939, the board selected design Bravo Bravo 65-5 Alpha, 12 16-inch guns on a displacement of 57,500 long tons, capable of 28 knots. External armor belt rather than the internal belts used on South Dakota and Iowa classes. External armor was easier to repair after battle damage. Weight savings from internal belts no longer mattered when displacement limits had been removed. The design was redesignated Bravo Bravo 67-1 when hull numbers 65 and 66 were reassigned to additional Iowa-class battleships. Design refinement continued through 1940. In March, engineers reverted to externally mounted armor. The internal belts of South Dakota and Iowa classes saved weight but complicated repairs. Incoming projectiles would pierce the outer hull before striking armor. Shells at the waterline could cause flooding regardless of whether they penetrated the belt. Accessing damaged internal armor required cutting through the hull. Repair times at forward bases would be unacceptable. The final design, dated March 1941, was designated Bravo Bravo 67-4. The specifications were extraordinary. Length overall, 921 feet 3 inches. Waterline length, 890 feet. Beam at waterline, 115 feet. Maximum beam, 121 feet 2 inches. Draft at standard displacement, 35 feet. Draft at emergency load, 36 feet, 10 inches. Standard displacement, 60,500 long tons. Full load displacement, 70,965 long tons. Emergency displacement, 71,922 long tons. Too wide for the Panama Canal by 13 feet 2 inches. Propulsion would consist of 8 Babcock and Wilcox oil-fired boilers generating 565 pounds per square inch of steam pressure. Superheat temperature, 650 degrees Fahrenheit. 4 sets of General Electric geared turbines. Total shaft horsepower, 172,000. Maximum speed, 28 knots. Range at 15 knots, 15,000 nautical miles. Less powerful than Iowa's 212,000 horsepower plant. But the reduced power enabled extensive subdivision of machinery spaces. Boilers and turbine rooms could be separated by multiple watertight bulkheads. The machinery arrangement resembled that of the Lexington-class battlecruisers, with boiler rooms flanking the central turbine rooms for inboard shafts. Wing shaft turbine rooms were positioned aft. This configuration provided exceptional survivability against underwater damage. The armor scheme represented a fundamental return to American battleship philosophy. Main belt armor, 16.1 inches of Class Alpha armor, mounted on 1 inch of special treatment steel backing. Total effective thickness, 17.1 inches. The belt was mounted externally on the hull. At the waterline, the belt began to taper, reducing to 10.2 inches at its lower edge. The belt extended from the forward main battery barbette to the aft barbette, protecting the ship's vitals within an armored citadel. Belt inclination, 19 degrees from vertical. This increased effective thickness against plunging fire and flat trajectory shells. The main armored deck consisted of 3 layers. Weather deck, 2.25 inches of special treatment steel designed to detonate shell fuses prematurely. Main armored deck, 7.05 inches of Class Beta armor covering the citadel. Splinter deck, 1 inch of special treatment steel to contain fragments. Total horizontal protection, approximately 10 inches equivalent thickness against armor-piercing bombs and plunging shell fire. Turret armor exceeded anything previously mounted on American battleships. Turret faces, 18 inches of Class Beta armor, mounted on 4.5 inches of special treatment steel. Total faceplate thickness, 22.5 inches, 3 inches thicker than Iowa-class turrets. Turret sides, up to 10 inches of Class Alpha armor. Turret roofs, 9.15 inches of Class Beta armor. Barbettes, 21.3 inches of Class Alpha armor forward, 18 inches aft. The conning tower sides received 18 inches of Class Alpha armor. These protection values were designed to withstand the super-heavy 16-inch Mark 8 armor-piercing shell at ranges between 18,000 and 31,000 yards. Against standard 16-inch armor-piercing shells, the immunity zone extended from 16,500 to 34,500 yards. Montana would be the only American battleship of World War II adequately armored against guns of her own caliber. Iowa-class battleships, by comparison, had 12.2 inches of belt armor inclined at 19 degrees. Their turret faces measured 19 inches. They were not designed to withstand their own gunfire. The torpedo defense system incorporated hard lessons from previous designs. 4 internal longitudinal bulkheads behind the outer hull formed a multi-layered bulge system. The 2 outer compartments would be liquid-loaded with fuel oil or seawater to disrupt the gas bubble from a torpedo warhead detonation. The bulkheads would elastically deform to absorb explosive energy. The 2 inner compartments would remain void. The lower-class Beta armor belt formed the holding bulkhead between them. System depth, 20 feet 6 inches. This compared to 18 feet 6 inches on North Carolina-class and 17 feet 9 inches on Iowa-class. The greater beam of Montana allowed significantly deeper torpedo protection. Tests conducted in 1939 had revealed a critical flaw in South Dakota and Iowa torpedo defense schemes. Extending the main armor belt as a torpedo bulkhead caused detrimental flooding due to belt rigidity. Montana's external belt and separate torpedo bulkheads eliminated this vulnerability. The main battery represented the most powerful broadside ever designed for an American warship. 12 16-inch 50 caliber Mark 7 guns, 4 triple turrets arranged in 2 super-firing pairs forward and aft. Each gun weighed 239,000 pounds. Barrel length, 66 feet 8 inches. The guns fired 2 types of shells. Armor piercing, 2,700 pounds. High-capacity explosive, 1,900 pounds. Muzzle velocity of armor-piercing shells, 2,500 feet per second. Maximum range at 45 degrees elevation, 42,345 yards, 24.03 statute miles. Flight time at maximum range, 82 seconds. At 20,000 yards, the armor-piercing shells could penetrate 20 inches of steel armor plate. At 30,000 yards, they could defeat 16 inches of armor. The guns could maintain a firing rate of 2 rounds per minute per gun. A full broadside of 12 guns delivered 32,400 pounds of armor-piercing projectiles every 30 seconds. For comparison, Iowa-class battleships mounted 9 16-inch 50 caliber Mark 7 guns. Their broadside weight, 24,300 pounds. Montana's broadside was 33% heavier. Secondary armament consisted of 25-inch 54 caliber Mark 16 dual-purpose guns mounted in 10 twin turrets. These guns could engage both surface targets and aircraft. Maximum range against surface targets, 13 statute miles. Maximum ceiling against aircraft, 37,200 feet. Rate of fire, 15 to 20 rounds per minute per gun. Close-in anti-aircraft defense included up to 40 Bofors 40mm guns and 56 Oerlikon 20mm cannons. The exact configuration varied in different design iterations as the war progressed and anti-aircraft requirements evolved. Fire control equipment would be state-of-the-art. 2. Mark 38 main battery directors with Mark 8 fire control radar. 4. Mark 37 secondary battery directors for the 5-inch guns. Multiple Mark 51 directors for 40mm guns. The Mark 38 system could maintain a constant firing solution even during radical maneuvering at high speed. 3 float planes for reconnaissance and gunnery spotting would be carried on the fantail with 2 catapults. Crew complement at standard, 115 officers and 2,240 enlisted men. As flagship, 189 officers and 2,789 enlisted men. On July 19, 1940, the Two-Ocean Navy Act authorized construction of 5 Montana-class battleships. Funding was provided in fiscal year 1941. The lead ship, USS Montana, hull number Bravo Bravo 67, would be built at Philadelphia Navy Yard, USS Ohio. Bravo Bravo 68, also at Philadelphia. USS Maine, Bravo Bravo 69, at New York Navy Yard in Brooklyn. USS New Hampshire, Bravo Bravo 70, also at New York. USS Louisiana, Bravo Bravo 71, at Norfolk Navy Yard. The name Montana was formally assigned on December 28, 1940. Construction was scheduled to begin in fiscal year 1942. Philadelphia Navy Yard prepared building way number 1 for Montana. The way would need to be lengthened to accommodate the 921-foot hull. New crane systems were installed. The building shed was expanded. Material procurement began. Steel suppliers received preliminary orders. Armor plate manufacturers began production planning. Then Pearl Harbor. The attack fundamentally altered American naval construction priorities overnight. Before December 7, 1941, the United States Navy operated 7 aircraft carriers, 3 in the Pacific, 4 in the Atlantic. After Pearl Harbor, With the Pacific Fleet's battleship force crippled, carriers became the only means of projecting power across the Pacific. Within weeks, the Navy revised its shipbuilding program. Priority shifted decisively toward aircraft carriers. The Essex-class carrier program, already underway, received accelerated funding. 24 Essex-class carriers would eventually be ordered. Production of escort carriers expanded dramatically. Light carriers converted from cruiser hulls received approval. Montana-class construction was deferred, but not yet canceled. Between January and May 1942, naval combat in the Pacific demonstrated the new reality. On February 19th, Japanese carrier aircraft struck Darwin, Australia. On March 10th, carrier aircraft from USS Lexington and USS Yorktown struck Japanese positions at Lae and Salamaua, New Guinea. On April 18th, 16 B-25 bombers launched from USS Hornet struck Tokyo in the Doolittle raid. Then came the Coral Sea. May 4th through 8th, 1942. The first naval battle in history where opposing fleets never sighted each other. Aircraft carriers engaged at ranges exceeding 100 miles. Surface ships played supporting roles. USS Lexington was sunk, USS Yorktown damaged. Japan lost the light carrier Shoho. The fleet carrier Shokaku was heavily damaged. The battle was tactically inconclusive, but strategically significant. Carriers had proven they could decide battles at ranges beyond which battleships could even see their targets. On May 20, 1942, construction of Montana-class battleships was formally suspended. No keels had been laid, no steel cut. The official reason given was material shortages and urgent requirements for other vessel types. Resources previously allocated to Montana would be redirected to carriers, destroyers, submarines, and amphibious vessels. The suspension was presented as temporary. 4 weeks later came Midway. June 4 through 7, 1942. Admiral Isoroku Yamamoto commanded the Japanese fleet from the bridge of the super battleship Yamato, 900 feet long, 72,000 tons displacement, 9 18.1-inch guns. The largest, most powerful battleship ever constructed. She and her sisters were designed specifically to defeat any American battleship that could fit through the Panama Canal. Yamato never fired her main battery during the battle. American carrier aircraft from USS Enterprise, USS Hornet, and USS Yorktown struck the Japanese carrier force at ranges exceeding 200 miles from Yamato's position. 4 Japanese fleet carriers were sunk. Akagi, Kaga, Soryu, Hiryu. 332 Japanese aircraft lost along with their highly trained air crews. The Kido Butai, the carrier strike force that had attacked Pearl Harbor, was effectively destroyed. Yamato could do nothing but watch. The battle lasted 3 days. At no point did opposing surface forces come within gun range. The decisive weapons were aircraft, not battleship guns. The battle demonstrated that the era of the gun-armed capital ship deciding fleet actions was over. Carriers, not battleships, would determine control of the sea. But old assumptions die slowly. Throughout the remainder of 1942 and into 1943, Montana-class construction remained in suspended status. Navy leadership debated whether circumstances might change. Perhaps a decisive surface engagement would occur that would vindicate the battleship concept. Perhaps technological developments would alter the equation. Perhaps the 5 Montana-class ships could serve as powerful shore bombardment platforms and anti-aircraft escorts for carrier task forces. This last possibility was examined in detail. Montana's 28-knot maximum speed presented a problem. Essex-class carriers could sustain 32 knots. The fast carrier task forces were designed around 33-knot Iowa-class battleships. Montana would struggle to keep up during high-speed operations. She would either slow the task force or be left behind. Her inability to transit the Panama Canal created additional complications. A Montana assigned to the Pacific Fleet would be trapped there for the duration. She could not be quickly repositioned to the Atlantic if circumstances required. She would need to sail around South America via Cape Horn, adding thousands of miles and weeks of transit time to any ocean-to-ocean transfer. Shipyard capacity presented another factor. Each Montana-class battleship would require approximately 4 years to complete from keel laying to commissioning. 4 years of occupying a major building way that could instead produce multiple destroyers, destroyer escorts, or submarines. 4 years during which the material and labor could complete escort carriers that would be operational in 12 months. The strategic calculus became increasingly clear through early 1943. At Guadalcanal, carrier air power had been decisive. At the Battle of the Philippine Sea in June 1944, aircraft would dominate completely. At Leyte Gulf in October 1944, the last major battleship surface action would occur at Surigao Strait, but carrier aircraft would sink the super battleship Musashi before she could engage. By mid-1943, American war production was hitting its stride. Essex-class carriers were being completed at 3-month intervals. Destroyer production exceeded 100 hulls per year. Escort carriers were being mass-produced using merchant ship construction techniques. Submarines were being delivered at a rate of 4 per month. The question facing Navy leadership was no longer whether Montana-class battleships would be useful. The question was what would not be built if Montana construction proceeded. Every ton of steel, every riveter, every welder, every engineer allocated to Montana was being diverted from platforms that were actively winning the war. On July 21, 1943, the Bureau of Ships issued the cancellation order. All 5 Montana-class battleships were formally stricken from the Naval Register. No compensation for contractors. No effort to salvage partially completed work. There was no partially completed work. Not a single component had been manufactured. The ships existed only as blueprints and scale models. The decision was final and absolute. Those blueprints and models revealed what might have been. Montana would have outclassed every battleship except Yamato in protection and firepower. She would have rivaled Yamato in armor thickness and exceeded her in some areas. The 22.5-inch turret faces on Montana compared to 25.6 inches on Yamato. But Montana's armor was higher quality American Class Alpha and Beta steel compared to slightly inferior Japanese metallurgy. Effective protection was nearly equivalent. Montana's 12 16-inch guns compared to Yamato's 9 18.1-inch guns. Yamato's shells were larger and heavier. 3,200 pounds versus Montana's 2,700 pounds. But Montana could fire faster and had superior fire control. American Mark 7 guns could maintain 2 rounds per minute. Japanese Type 94 guns manage 1.5 rounds per minute. Montana's broadside weight over time would actually exceed Yamato's. The real advantage would have been American radar fire control. The Mark 38 Director with Mark 8 radar could accurately engage targets beyond visual range. In night actions or reduced visibility, Montana would hold a decisive edge. Japanese optical rangefinders were excellent, but required clear weather and good visibility. American radar worked regardless of conditions, but this hypothetical engagement would never occur. By the time Montana could have been completed in 1946 or 47, Yamato had been sunk, Musashi had been sunk. The era they represented had ended. What Montana represented was the culmination of battleship design philosophy. Every lesson learned from 3 decades of capital ship construction had been incorporated. The armor scheme balanced protection against contemporary threats. The torpedo defense system reflected actual combat experience. The fire control systems utilized the latest radar technology. The damage control arrangements provided exceptional survivability. She would have been, in many respects, the perfect battleship for a war that was no longer being fought. The 4 Iowa-class battleships that were completed saw extensive service. They screened carrier task forces throughout the Pacific campaign. Their 33-knot speed allowed them to operate with the carriers. Their massive anti-aircraft batteries provided critical protection. At Leyte Gulf, USS Iowa and USS New Jersey participated in the pursuit of the Japanese Northern Force. At Okinawa, all 4 Iowas provided fire support and anti-aircraft defense. After World War II, the Iowas remained in service. They bombarded targets during the Korean War. USS New Jersey shelled positions in Vietnam. All 4 were modernized in the 1980s with Tomahawk cruise missiles and Harpoon anti-ship missiles. They participated in operations during the Gulf War. The last Iowa-class battleship, USS Missouri, was decommissioned in 1992. Montana would have faced a different fate. Her slower speed would have made her less useful in the fast carrier task force role. Her inability to transit Panama would have limited her operational flexibility. Her enormous size would have complicated refitting and modernization. The cost to maintain her in the reserve fleet would have been prohibitive. Most likely, Montana and her sisters would have been completed too late to see combat in World War II. They would have entered service in 1946 or 47 after Japan's surrender. A brief period of active service would have followed, perhaps in training or ceremonial roles. By the early 1950s, with the Navy shifting toward carriers and guided missiles, the Montana class would have been declared surplus. The most probable outcome, scrapping by 1960. Instead, the resources allocated to Montana built weapons that won the war. The steel went into carriers and destroyers. The shipyard capacity produced submarines and landing craft. The labor constructed the vessels that island-hopped across the Pacific, that screened the carrier task forces, that torpedoed Japanese convoys, that landed Marines on hostile beaches. 21,000 tons of armor plate that would have protected Montana's vitals instead became armor for dozens of cruisers and destroyers. 172,000 shaft horsepower worth of turbines and boilers instead propelled multiple escort carriers. The 12 turrets that would have housed Montana's main battery became components in coastal defense installations and testing facilities. Nothing was wasted. Everything was reallocated. The men who would have crewed Montana, the 2,350 officers and sailors, instead served on operational vessels. Some crewed Iowa-class battleships. Others served on carriers, cruisers, destroyers. They fought at Philippine Sea, Leyte Gulf, Iwo Jima, Okinawa. They participated in the actual war rather than manning a ship that represented a past vision of naval warfare. Of the 5 names assigned to Montana-class hulls, 4 would eventually be used again. USS Ohio became a ballistic missile submarine, commissioned in 1981. USS Maine became another ballistic missile submarine, commissioned in 1995. USS New Hampshire became a Virginia-class attack submarine, commissioned in 2007. USS Louisiana became a ballistic missile submarine, commissioned in 1997. Only Montana herself never had her name assigned to another hull. The name remains available, waiting, at the Naval History and Heritage Command in Washington. The plans for Montana-class battleships occupy several file cabinets, 23,000 sheets of technical drawings, armor schemes, machinery arrangements, electrical systems, weapons placements, damage control stations, everything required to build the largest battleship the United States Navy ever designed. Scale models exist at several locations. The most detailed is at the Naval Academy Museum in Annapolis, 9 feet long, carved from wood, painted in wartime camouflage pattern. 4 triple turrets fore and aft, 10 twin 5-inch mounts along the superstructure, anti-aircraft batteries covering every angle, 3 aircraft on the fantail. She looks powerful, purposeful, perfectly proportioned. She looks ready for a war that never happened. The historical significance of Montana lies not in what she accomplished, but in what she represents. She represents the last gasp of battleship supremacy, the final attempt to build an armored gun platform that could dominate sea combat through firepower and protection. She represents 3 centuries of naval thinking, from ships of the line to dreadnoughts to super-dreadnoughts. She represents a vision of warfare that Pearl Harbor and Midway rendered obsolete in 6 months. The aircraft carrier, Montana's executioner, proved to be the correct answer to the question of naval dominance. Carriers could strike at ranges of hundreds of miles. They could launch multiple strikes per day. They could be repaired and rearmed relatively quickly. They could operate in weather conditions that grounded surface gunnery. They could adapt to changing tactical situations by altering their air groups. Battleships, even super battleships like Montana, could do none of these things. By July 1943, when Montana was canceled, American intelligence had become aware that Japan had built the Yamato-class super battleships. Details remained sketchy. The displacement was unknown. The armament was incorrectly estimated as 9 16-inch guns rather than the actual 9 18.1-inch guns, but the existence of Yamato and Musashi was confirmed. This intelligence had influenced Montana's design, but it could not save Montana from cancellation. Because regardless of Japanese battleship capabilities, regardless of American responses, the fundamental equation had changed. Aircraft carriers, not battleships, would determine the war's outcome. Yamato herself demonstrated this conclusively. On April 7, 1945, she sortied from Japan as part of Operation Ten-Go, a suicide mission to beach herself at Okinawa and use her guns as shore batteries. She never arrived. 386 American carrier aircraft attacked her task force. Yamato took 10 torpedo hits and 7 bomb hits. She capsized and exploded, taking 2,498 of her 2,700 crew with her. Montana, had she been completed, would likely have met a similar fate. Enormous, Powerful, impressive, ultimately helpless against mass air attack. The last American battleship ever authorized. Montana represented the end of a lineage stretching back to USS Texas. Launched in 1892, 51 years of American battleship development. From pre-dreadnoughts to super-dreadnoughts. From coal to oil. From reciprocating engines to turbines. From riveted construction to welded. From optical directors to radar fire control. Montana would have been the culmination. The apex, the ultimate expression of the armored gun platform concept. And she was obsolete before her name was assigned to a hull number. Today, students of naval history study Montana as the might have been. Alternative history enthusiasts speculate about Montana versus Yamato engagements. Naval architects analyze her armor scheme and torpedo defense. Model builders construct detailed replicas. Video games include her as a playable ship. She exists everywhere except in steel and water. The lesson of Montana is not about the ship herself, but about strategic adaptation. The United States Navy in 1943 made the correct decision. They recognized that past success does not guarantee future relevance. They understood that sunk costs are sunk, that emotional attachment to previous capabilities must yield to operational requirements. They accepted that the weapons needed to win the current war differ from the weapons that won the previous war. Montana represented the last war. Carriers represented the current war and the next war. The Navy chose correctly. 4 Iowa-class battleships survived to become museum ships. USS Iowa in Los Angeles, USS New Jersey in Camden, New Jersey, USS Missouri in Pearl Harbor, USS Wisconsin in Norfolk. Millions of visitors have walked their decks, stood in their turrets. Imagine the thunderous roar of 16-inch guns firing. Montana exists only in archives and imagination. No tourists will ever walk her decks. No guns will ever fire from her turrets. No crew will ever bring her to life. She is the ghost of a future that never arrived. The promise of firepower that became irrelevant. The ultimate battleship for a form of warfare that ended before she could be built. On July 21, 1943, 5 names vanished. 5 hulls were never built. 70,000 tons of battleships ceased to exist without ever existing. The age of the armored gun platform ended not with a final salvo, but with a bureaucratic memorandum. And the United States Navy never built another battleship.